Okay, so we have this physics problem, and it says Vegeta is standing on the edge of a 275-meter high cliff and shoots an energy blast straight up with an initial velocity of 29.5 meters per second. The energy misses the edge of the cliff as it falls back toward the Earth. Calculate its position and velocity of the blast at 1, 2, 3, 4, 5, and 6 seconds after a shot, neglecting the effects of air resistance. So to begin, we draw a diagram, label our parameters, and make sure that we're clearly labeling what we're looking for. Things like acceleration, velocity, and time, and the change in y. Once you make the appropriate diagram and do all your hash marks, then you can proceed mathematically. We'll use our free fall motion equations, and to calculate for velocity, we'll use this one, and we'll calculate our first velocity. And then for change in position, we're going to use this formula right here, or the kinematic equation for free fall, to find the change in position. And then we're going to get 300 meters for the first change in position after 1 second. Then we're going to do it again using the same equation to find the position or the velocity at 2 seconds and the position at 2 seconds. And it's going to be another step, like rinse and repeat the same thing, plugging in the velocity, again, the initial velocity, the time. Since the gravity is already given as a constant, that's how we're getting those values there. And see, if you look at the change in y, everything is just plugging in the numbers, changing it to 3 seconds, and then squaring the time. So as we continue to go through it, you notice the trend. To look at the energy blast going up, and then it going down, and then now we're at 6 seconds, and notice that the energy blast is right back to where it started. This is a velocity versus time graph showing the velocity as, notice that it's always constantly decreasing because gravity is pulling it downward. And then this is the position versus time. It's almost like, looks like a bell curve kind of. See how it goes back up just like the diagram and goes back down. And one thing you'll notice, it just looks like a straight line where it has no slope, and that's the reason is because the acceleration is a constant. I hope this kind of explains free fall a little better for you. Thank you.